In this video we're going to consider what's going to happen to the graph of the function f of x is equal to 1 over x. To start this, we're going to draw it. If we switch on the calculator and press y equals, we can enter in the function 1 divided by x. If we graph this, we see that the function has these lines coming down here, then down from here and across. We want to use limits to investigate, does this value reach the y-axis, or does the line reach the x-axis in this direction? And it doesn't. So in order to investigate it, if we use limits to see what happens as bigger and bigger, we can put up the equation, investigate what happens to the function as x becomes bigger and bigger using limits. That would be the limit as x approaches infinity of the function 1 over x. We can use the calculator to make these calculations. If we press the variables button, y variables and function, and y1, we can see what happens as we put in a large number like 1000. This is going to be 0.1. So 10 to the 3, and we get 0.001. We put in a larger number, 10 to the 5, we're going to get an even smaller number. So as this one goes up, 10 to the 5, this one goes down, 10 to the minus 5. Repeat it one more time. Put in 10 to the 7, and this becomes 10 to the 7. This is going to be 10 to the minus 7. So as these numbers get bigger and bigger, these numbers are going to get smaller and smaller. We say that the function will approach a value of 0 as x approaches infinity. Now, if we see on the graph, we can see this happening. We can see that as we get bigger and bigger, this gets closer and closer. Do they cross? No. We can never make x reach infinity, so we can never make the function reach 0. We can only say that at the limit as x approaches infinity, then the function will approach 0. Let's investigate what happens to the function as we let x approach 0. That means that we can put up a value such as x approaches 0. Now in this case it's going to differ depending on whether we approach it from the right hand side or when we approach from the left hand side. To have values which are larger than 0, we're approaching in this direction, and we can denote that with a small plus symbol here. As we take our function and put in smaller and smaller values, let's start off at 0.1. If we enter in 0.1, the answer will be 10. Repeat that for 0.01, the answer is going to be 100. And again, bigger values, smaller, as we get closer and closer to 0, these values will get bigger and bigger. So at 0.01, we're going to get 100, 0.001, we get 1000. We say that the limit as x approaches 0 from the right hand side of 1 over x is going to be equal to infinity. It'll continue up. But we get a different result when we investigate what happens to the function's value as x approaches 0, while all at the same time being smaller than 0. That means we're approaching the function from the left hand side. We make the values go to 0 in this direction, and we can see that we're going to get a different value. We can say this algebraic with the limit of x approaches 0, and then use a minus sign to say from values to the left hand side of the function 1 over x. If we calculate this now, to get a value from the left hand side it needs to be negative, such as 0.1. This is going to give us minus 10. If we repeat, 0.01 minus 100. Repeat, 0.001 minus 1000. We can say that in that case, the limit of the function as x approaches 0 from the left hand side of the function 1 over x will be minus infinity. Will the function ever have the value of infinity, either here or negative or positive? No, It can't. We have to use limits. We cannot have x become 0, because we'll get a divide by 0, and this isn't allowed. So we say that the function is never equal to infinity. The variable x will never be 0, but as it approaches 0, it will approach either infinity or negative infinity, depending from which side we approach 0.